In a Chinese export catalog, a 6-axis agricultural drone is listed at $3,499 free on board. In a robotics specialty store, a quadruped robot dog is listed at $3,500. On NVIDIA's developer portal, the Jetson AGX Thor compute module is listed at $3,499, and in a Western consumer technology feed, all three numbers collide into a single viral headline. A Chinese farming robot, priced at $3,499, will shock the entire world. The hardware exists. The pricing is real. 2024 saw Chinese factories install nearly 300,000 new industrial robots, more than the United States, Japan, Germany, and South Korea combined. Domestic supply chains are vertically integrated to a degree no Western competitor can replicate. State subsidies push agricultural drones into the international export market at margins approaching zero. But there is no $3,499 farming robot, not in the way the headline frames it. The number buys the propulsion, the chassis, or the brain, not all three, and rarely the implements that actually do the farming. The platform that actually performs the work depicted in the viral footage costs nearly 10 times more once it is configured for real field work. Welcome back to the channel. We are going to walk through the so-called $3,499 farming robot the way it looks at the procurement desk, not the way it looks in the viral feed. The argument rests on three claims. First, that $3,499 buys an autonomous Chinese farming robot capable of replacing tractor labor. Second, that this represents an existential shock to Western agricultural machinery makers like John Deere, Robotics, and Monarch Tractor. Third, that this is a generational inflection point in the global farming labor equation. We will grant that Chinese industrial robotics has achieved a real, structural cost advantage, and then we will show why $3,499 is a sticker price for a chassis, not a working farm, and why the actual disruption is narrower than the headline implies. The entire story turns on what the number actually buys. Candidate 1. The Hunan Soaring Times 2026 Agricultural Drone Sprayer. 6-axis hexacopter, payload 30 to 50 liters, 12 meters per second, terrain-following radar, dual GPS. FOB export price is between $3,299 and $3,499. That price is the chassis and standard nozzles. It does not include high-discharge smart batteries or the real-time kinematic ground station. A field-ready configuration runs closer to $8,000. Candidate 2. The FJ Dynamics RM21 robotic mower, wheeled electric RTK GPS guided, listed at exactly $3,499. A precision groundskeeping tool. With professional RTK mapping and the auto steering subscription, deployed cost lands around $6,500. Candidate 3. The Unitree Go-To PRO quadruped, priced at $3,500 exactly. 4D LiDAR, 16-core CPU, 1.5 teraflops of onboard compute. It walks at 3.5 meters per second, climbs stairs, traverses mud. It can also do absolutely zero physical farming. It is an inspection platform, terrain mapping, livestock monitoring, thermal crop imaging. It does not spray, it does not seed, it does not harvest. Candidate 4 is not a robot at all. It is the NVIDIA Jetson AGX Thor Developer Kit, released August 2025 at exactly $3,499. The Edge AI compute module that goes inside next-generation humanoids, autonomous tractors, and agricultural drones. The brain, not the body. Conflating brain pricing with chassis pricing is one of the most common errors in this category of reporting. And the platform actually depicted in most of the viral footage, the XAG R150 unmanned ground vehicle, has a base vehicle price of $22,000 to $32,000. The Revo Spray module costs $7,806. The Revo Mower costs $8,862. Each smart battery costs $1,200. A day-long field kit needs 4 to 8. Add the field charger at $2,688 and a local network terminal at $3,500. A fully configured XAG R150 optimized for autonomous orchard spraying realistically costs between $35,000 and $48,000. So the headline number is real, it just does not buy what the headline is selling. The reason the chassis can be sold at $3,499 is the Chinese manufacturing base, not the agricultural sector. Agriculture is the downstream beneficiary of an industrial flywheel built over the last decade. In 2024, Chinese factories installed approximately 295 to 300,000 new industrial robots, over 54% of global installations. The United States installed 34,200, Japan, 44,500, South Korea, 30,600, Germany, 27,000. More than the next 4 countries combined. Over 2 million industrial robots now operate inside Chinese factories. That density forces commoditization. Unitree produces its own proprietary motors for $369 per unit. Chinese 4D LiDAR modules sell for $249 to $419. A decade ago, comparable LiDAR sensors cost several thousand. The Ministry of Agriculture's National Smart Agriculture Action Plan mandates that more than 30% of domestic agricultural production be managed by autonomous systems by the end of 2026. Provincial governments in Shandong, Henan, and Heilongjiang provide direct rebates to farmers purchasing XAG and DJI platforms. The export pricing, the 3,499 sticker, is a deliberate loss leader. Manufacturers absorb razor-thin or negative margins on base hardware. The strategic objective is ecosystem lock-in. Once a farm adopts a chassis, the operator is bound to that manufacturer for proprietary battery replacements, software licensing, RTK subscriptions, and replacement parts over the decade-long lifespan of the equipment. The chassis is the entry token. The recurring revenue is the product. The first-order implication is on agricultural geography. Chinese platforms genuinely deliver more useful work per dollar than Western alternatives in 3 specific environments: terraced rice paddies, dense orchards, and high-value specialty crop operations on small parcels. A landmark deployment of the XAG R150 in Takayama, Japan, demonstrated automated apple orchard pollination, addressing both Japan's aging farm labor demographic and the regional collapse of natural bee populations. Where heavy Western broadacre machinery cannot physically enter, Chinese lightweight platforms have a durable structural advantage. The second-order implication is on global manufacturing balance. Analyst forecasts project China will hold 70 to 80% global market share in lower-cost edge robotic platforms through 2026. Western manufacturers will compete on capability, durability, and integration, but the cheap end of the market is structurally Chinese. The third-order implication is on the speed of physical world AI deployment. American firms still dominate the cognitive layer. NVIDIA's monopoly on high-end edge compute is the obvious example. The Jetson AGX Thor sits inside Chinese drones, John Deere combines, Boston Dynamics platforms, and Aptronic humanoids alike. But Chinese firms, XAG, DJI, Agibot, Unitree, are deploying vision language action models into the field at a tempo Western firms cannot match. American firms wait for safety certifications and regulatory clearance. Chinese firms ship hardware and iterate on the data the deployed fleet generates. The hardware lead generates the data lead. Here is the part the headline skips. There are 7 taxes against the 3,499 framing, and they compound. First, the implement illusion. The base price buys the chassis, propulsion, and basic navigation. It does not buy the implements that physically interact with the crop. The XAG R150 without a RevoSpray module is a wheeled battery. The RevoSpray costs $7,806. The RevoMower costs $8,862. Configured cost runs 3 to 10 times the base sticker. Second, software subscription lock-in. Modern Chinese platforms require ongoing licensed access to RTK correction streams, autonomous steering algorithms, and proprietary cloud farm management. FJ Dynamics auto steering activation is a separate license. XAG Cloud Access is a separate subscription. These ecosystems are not optional, they are the system. Third, after-sales fragility. The most underrated moat John Deere holds is its dealer network. Several thousand dealerships across North America, each with trained technicians, diagnostic tools, and parts depots. If a Chinese unmanned ground vehicle suffers a critical fault during a 14-day harvest window in the American Midwest, the operator has no local technician, no diagnostic toolkit, no replacement parts depot. A weather-driven harvest delay can cost a farmer multiple times the purchase price of the robot. Fourth, crop type mismatch. Chinese robotic kinematics are exquisitely tuned for high-density, terraced, specialty crop environments native to East Asia. They are not optimized for broadacre wheat, corn, and soybean operations across the American Midwest, the Brazilian Cerrado, or the Australian wheat belt. A John Deere self-propelled sprayer carries over 1,000 gallons of payload. The XAG R150 carries 39 gallons. To match broadacre throughput, the Chinese platform requires a synchronized swarm, with compounding logistics for battery management, refilling, and fleet control. Fifth, subsidy distortion. The upfront hardware cost is artificially depressed by Chinese provincial subsidies. The sticker does not represent a free market manufacturing cost. International buyers who build operations on subsidized imports are exposed to tail risk, anti-dumping tariffs, sudden trade barriers, or removal of the subsidy itself. Sixth, export control friction. The advanced edge compute platforms inside high-end Chinese robots, including the Jetson AGX Thor, rely on US-derived silicon architecture. As Western export control frameworks tighten on advanced semiconductors flowing into China, the supply of compute modules becomes a contested choke point. A Chinese platform reliant on US chips can be frozen mid-product cycle. And seventh, reliability and life cycle durability. Hardware costs are dropping. Hardware reliability in extreme conditions is not. Agricultural environments combine extreme thermal loads, abrasive dust, and corrosive chemicals. Chinese ag robotics historically lag behind Japanese and Western incumbents in decade-long durability. The Yamaha R-Max served Japanese rice paddies for decades. The longest deployed XAG fleet has been operating commercially for under 5 years. These 7 taxes do not eliminate the Chinese cost advantage. They bound it. The sticker is real. The total cost of ownership is not. So the honest answer to whether the new Chinese 3499 farming robot will shock the entire world is, it will shock parts of it. Specific parts, not all of it. On one road, Chinese platforms scale aggressively into Asian and Global South specialty crop markets. Terraced rice paddies, orchard pollination, vineyard slashing, small parcel spraying across Southeast Asia, Latin America, and parts of Eastern Europe. The 70 to 80% global market share forecast holds. Western firms cede the small parcel segment entirely. The platforms reshape the labor equation in countries with aging farming demographics like Japan, Korea, and parts of Southern Europe. The inflection point lands within 5 years. On the other road, the counterargument tax holds. The implement gap, the support network gap, and the broadacre kinematic mismatch lock Chinese platforms out of the American Midwest, the Brazilian Cerrado, and the Australian wheat belt. John Deere holds those markets through dealer infrastructure, decadal mechanical durability, and capital finance integration no Chinese exporter can replicate at scale. Carbon Robotics holds the high-end specialty crop laser weeder tier. Monarch Tractor holds the compact electric tractor tier in U.S. vineyards. Swarm Farm and Nio hold the European and Australian niches. The Chinese platforms generate viral coverage, but do not displace the actual capital base of global agriculture. Both roads are operating simultaneously. Chinese platforms are dominating the lower-cost specialty crop segment and not displacing the high-payload, decadal durability, broadacre tier, where the bulk of global agricultural revenue sits. The shock is real, and it is segmented. The price is real. The framing is not.